Welcome everyone. This is the 8th video of our data science series. In this video, we will going to learn k-means clustering and introduction. What is k-mean clustering? Clustering is an unsupervised learning technique used to group similar data points together. K-mean clustering is a popular algorithm for partitioning data into clusters. It is a simple yet powerful technique suitable for various applications. Introduction to clustering. Unsupervised learning. Clustering algorithms learn patterns in data without labeled examples. Grouping similar data. Data points within a clusters share common characteristics, differentiating them from other clusters. Discovering hidden structures. Clustering reveals underlying structures and relationships within data. Applications in various fields. Clustering has applications in customer segmentation, image analysis, and more. What is k-mean clustering? Initialization. Randomly select k data points as initial cluster centers. Assign step. Step number 2. Assign each data points to the closest cluster center based on distances. Step number 3. Update step. Recalculate cluster centers as the mean of all points assigned to that cluster. And step number 4, which is our last step also, repeat step 2 and step 3. Iteratively repeat the assignment and update steps until cluster center stabilize. Assumptions and limitations of k-means. Assumptions. Data is conscious. Clusters are spherical. Clusters have similar sizes. What are the limitations of k-mean clustering? We will see here. Sensitive to initial cluster centers, may struggle with non-superstitical clusters. Susceptible to outliers. Steps in implementing k-mean clustering. Load and prepare data. Import the dataset and handle any mission values or data transformations. Choose to the numbers of clusters. Determine the optimal numbers of clusters using methods like the elbow method or analysis. Run k-means algorithm. Use the k-mean functions in R Python to execute the algorithm and obtain cluster assignments. Visualize and interpret results. Create visualizations to understand the cluster structure and data meaningful conclusions from the result. Visualizing clusters in R Python. Scatter plots. Visualize clusters in two-dimensional space. Heat maps. Show clusters membership using color gradients. Dendrograms. Illustrate hierarchical clustering relationships. Evaluating cluster quality. Discriminating the optimal numbers of clusters. Elbow method. Plots WCSS against the numbers of clusters looking for an elbow point where the decrease in WCSS starts to level off. Shilhoti analysis calculates the scores for different numbers of clusters, seeking the highest average scores. Real-world applications of k-mean clustering. Customer segmentation. Group customers into distinct segments based on their purchasing behavior. Image compression. Compress images by grouping similar pixels together. Anomaly detection. Identify unusual data points that deviates from the normal cluster patterns. Conclusion and key takeaways. K-mean clustering is a valuable tool for discovering patterns and grouping data into meaningful clusters. It has wide-ranging applications in various fields. Understanding its assumptions and limitations allows for effective use and interpretation of the result. Thanks for watching. Let's catch in the next video. Thank you so much.